We're on problem 32. What are the solutions to the equation 1 plus 1 over x squared is equal to 3 over x? So at first this looks like a pretty daunting equation. You have these x's in the denominator and x squared in the denominator. But I think we can simplify it if we can just get rid of these x squareds in the denominator. The easiest way to do that is to multiply everything by x squared. So let's multiply both sides of this equation by x squared, and then we'll get, see, x squared times 1 is x squared. X squared times 1 over x squared, well, that's just 1. And then x squared times 3 over x, that's 3x squared over x. X squared divided by x is just x, so that is equal to 3x. We could subtract 3x from both sides, and you get x squared minus 3x plus 1 is equal to 0. And it's a simple quadratic. And it's not obvious that you can factor it. In fact, two numbers, when you multiply them, equal 1, and that when you add them, equal minus 3. I'm guessing it might be imaginary. Well, it might not be imaginary, but it's just a strange number. So let's use the quadratic equation. When in doubt, use the quadratic equation. So minus b, this is b, right? B is this 3 right there. The negative 3, right? B is negative 3. So minus b is going to be plus 3. Plus or minus the square root of b squared. Minus 3 squared is 9. Minus 4 times a, which is 1, times c, which is 1. So it's minus 4. All of that over 2a. A is 1, so it's just over 2. See, that is equal to 3 halves plus or minus, what's that, the square root of 5 over 2. I just separated these out because I was looking at the choices, and it seems like they did that. So you could say that's 3 halves plus square root of 5 over 2, or 3 halves minus the square root of 5 over 2. And I just did that because it seems like that's how they write it. And that is choice A. Next problem. 33. I think this one actually might be good to copy and paste the problem. Let me see if I can do this. Okay, there are two numbers with the following properties. Let me write down the properties, or let me copy and paste it for you. Okay, I've copied it, and then let me go here, and then I've pasted it for you. All right. Now, so the second number, so there's two numbers with the following properties. The second number is 3 more than the first number. So let's say S for second number and F for first number. So the second number is 3 more than the first number. So the second number is equal to the first number plus 3. That's from statement 1. And then the product of the two numbers is 9 more than the sum. So the product of the two numbers, that's S times F. S times F is 9 more, 9 plus their sum, plus S plus F. So let's see, we have two equations and two unknowns. This is nonlinear because I'm multiplying these two variables, but I think we should be able to solve them one way or the other. So let's see, we have what S is equal to. So let's just substitute that back into this equation. So let's say that S is equal to F plus 3. So if we substitute for these S's, we get F plus 3 times F is equal to 9 plus F plus 3, right, instead of an S. F plus 3, and then plus F. See if we can simplify this. F times F is F squared plus 3F is equal to 9 plus 3 is 12 plus 2F. Plus 2F. Let's see, subtract 2F from both sides, you get F squared plus F is equal to 12. Subtract 12, you get F squared plus F minus 12 is equal to 0. And this one looks factorable. I don't have to take out the quadratic equation. Let's see. This is F plus 4 times F minus 3, right? Because when you multiply those, you get negative 12. When you add those, you get plus 1. So that is equal to 0. So in order for this to be true, one or both of these have to be equal to 0. So if F plus 4 is equal to 0, F plus 4 is equal to 0, that means that F could be equal to minus 4. If F minus 3 is equal to 0, then that says that F could be 3. So F could be minus 4 or 3. Now S is F plus 3. So if we're dealing with the minus 4 scenario, If f is equal to minus 4, then what is s? Then s is going to be minus 4 plus 3, then s is going to be equal to minus 1. And that if f is equal to 3, then s is equal to 6. So let's see if we see either of these combinations. Minus 4, minus 1, that's choice B. Excellent. All right, problem 34. Problem 34. Let me see. Maybe I should copy and paste these word problems so we can see how we parse the problems. So I've copied it. And now let me go here. And then pasted it. Jenny is solving the equation x squared minus 8x equals 9 by completing the square. What number should be added to both sides of the equation to complete the square? So x squared minus 8x is equal to 9. And I wrote it with space for a reason. When you're completing the square, you're trying to turn the left-hand side of this equation into some type of a perfect square, right? So if it's a perfect square, I have two numbers, and it's the same number, that when you add them together, you get minus 8. And when you square them, you should get something else, right? So what's half of minus 8? Half of minus 8 is minus 4. And if I add 6, so minus 4 squared is 16. So if I add 16 to both sides, I'm all set. And why did that work? Well, now it's a perfect square. This is now x minus 4 squared is equal to 9 plus 6, 25. They're not even asking us to solve it. They just wanted to know what we had to add to both sides. So it's 16d. And remember, the whole logic here, and I've done a few videos on completing the square, is what number do I add here to make this a perfect square? And you say, okay, I have a minus 8x, so I take half of this number, right? Because the same number added to itself twice is going to become minus 8. I take half of that number and then I square it. So half of minus 8 is minus 4. And you square it, you get the 16. So add 16 to both sides, you get this. And you could actually solve for this. X minus 4 is plus or minus 5, and you'd keep going. And that's actually where the quadratic equation comes from. Anyway, next problem. And 16 was choice number D. All right. So they say, actually, I'm going to copy and paste this entire problem here. Let's go over here. You paste it here. Okay, which of the following most accurately describes the translation of the graph, okay, y is equal to x plus 3 squared minus 2 to the graph y equals x minus 2 squared plus 2. So this translations and all that, that's off. So the y translation, it tends to be pretty easy to figure out. Because if I have some, let me just draw some example graph. So if I had the graph x squared, the graph x squared looks something like this. See if I can draw it. The graph x squared looks something like this. Right? And there's x. When x is equal to 0, we're at our minimum point, right? And any other value increases in both directions. The graph of x squared plus 2, you're shifting up. Right? This is the graph of x squared plus 2. You would shift it up by 2. And the graph of x squared minus 2, you would shift down by 2. Right? This would be x squared plus 2. And this would be x squared minus 2. So the shift in the y direction is very easy to see. So if we're going from something minus 2, if we're going from something minus 2 to plus 2, so we're going from minus 2 to plus 2, we're going to be shifting it up 4, right? So that's always the easy one to just eyeball and figure out. So we're definitely going to be shifting from minus 2 to 2, so it's up 4. So it's either going to be choice A or choice D. The left-right shift is often a little bit more hard for people to visualize or to at least internalize, but I'll give you an attempt. If this is the graph, let's just go back to this. This is the graph of x squared, this yellow line right there, right? That's the graph of x squared. Now let me ask you a question. What is the graph of x minus, I don't know, x minus 3 squared? So does this shift it down 3 to the negative direction or 3 to the positive direction? Your intuition might say, oh, I'm subtracting 3. When I did a minus 2, I shifted down. But it's actually the opposite here. Because you have to think about, for what value of x am I going to have a 0 squared here, right? And that happens when x is equal to 3. So you can think of it this way. Now, when we're at this point, when x is equal to 3, it's the same thing as this point when we have just x squared, right? Because when you put 3 in here, this whole expression becomes 0. And as you get above 3, that's like going above 0. And as you go below 3, That's like going below 0. So this graph will just get shifted to the right by 3. Right? That's x minus 3 shifts to the right by 3. X plus 3 would go in the other direction, because when x is minus 3, that's when it would equal to 0. I haven't written that down. So let's think about this. We're going from x plus 3, right? So if this is x squared, x plus 3 is actually, it would look something, let me do it in a different color. X plus 3 is actually shifted to the left. And the way I always think about it, there's two ways to think about it. That the y shift isn't intuitive, and the x shift might not be. If you have a plus 3 here, you're actually shifting in the downward direction. And the way to actually think about that, the intuition is, when will this whole expression equal 0? This whole expression equals 0 when x is equal to minus 3. So that's the point at which you're getting 0 squared. And I actually didn't, when I'm drawing these graphs, I'm not doing the y shift here, right? So this is going to be shifted to the left 3. This is going to be shifted to the right by 2. So if this is shifted to the left 3 and this is shifted to the right by 2, to go from this to this, you're shifting to the right by 5, right? So, x plus 3 squared is here. So the actual graph, x plus 3 squared minus 2 it's going to be here, right? And then to go here, you have a plus 2, so you're shifting the graph up by 4, and then you're going to x minus 2. So this graph right here is going to be up here. So you're shifting up by 4, and then you're shifting to the right by 5. Actually, even if you're confused whether you're shifting left or right, you can just say, okay, the difference between plus 3 and minus 2 is 5, and 5 is only there. But you should hopefully understand the problems a little bit deeper than that. But anyway, I'll see you in the next video.